Hello and welcome to the Slingshot channel. Today we're going to talk about bolts and how they can be made better. Because I put a bolt in a bolt. The tungsten bolt in the bolt. Let me show you its features. So this is a typical air bolt, weighing 13 grams, and I think you all know it. It has a tip that can be removed, that's just a field tip. And the thing is that, of course, penetration is somewhat limited because the most powerful crossbow that can shoot this is the Siege. And the Siege has about 75 joule, which is maybe, I don't know, 50 something foot-pounds. And I made this one here. And what I did is I took the same tip and put it in the lathe. And actually what I did is I drilled it through. Let me see if the camera focuses on this. So as you can see, I drilled a hole through this so that this tungsten needle is fitting right through. And therefore, the needle actually can go all the way in until it reaches the knock. So I put in an aluminum knock, and I also put a nail through this. Let me see, the camera focuses. So you can see I put a nail through here because otherwise the knock would just simply pop out when the whole thing is accelerated. And as you see, when you insert it, it just looks almost like a normal field tip. But of course, tungsten is very heavy. It's about 3 times more dense than steel. So this needle here weighs an impressive 9.5 grams. So that is really, really heavy if you keep in mind that the whole bolt here only weighs 13 grams. So this is very interesting, and this of course means that now if this enters a target, theoretically, we will have to test this later on. So if this enters a target, at some point it will be decelerated because of the thick diameter of the bolt. But this one then will hopefully keep traveling, penetrating far more deeply than the bolt can do on its own. So of course, if I use a crossbow with 75 joule, that energy is split. When the thing enters the target, it will still have 75 joule, but then it will split, and this one here will then only have about 32 joule, while this one here will have the remaining 43 joule. So yes, the difference is that the diameter of this is only 1.8 millimeter. So this is far, far more narrow than this. So it has to shift a lot less material, just simply because the headspace is so much smaller. So theoretically, these here should penetrate far better, even though they don't have the same energy as this one. We will put this to the test. I made a total of 3 such bolts, and this one here I actually fixed with a tiny drop of glue, just to make sure that it's not falling out during acceleration or whatever. And this one here still has to be glued because it's just for demonstration purposes. It is not glued yet. Yeah, and then we'll test it. And we'll be using my much shortened Siege that I cut off to the bare minimum. So this is as small as it gets, and I think for a magazine-equipped crossbow, 75 joule is plenty. Still, penetration isn't great because this is not a hunting crossbow. That's a tactical crossbow. We'll see what happens. And this is one of the targets that we're going to use. It's the EK Archery mat. Now, this looks completely shot out, and it is kind of, but it's still stopping the bolts with high reliability. And that is because of the construction of the whole thing. So let me open this up for you. So you can see that they put foam in front, but behind the foam is this incredibly tough rubber mat. So this is so thick and tough that no bolt can actually penetrate. So this is the trick. The bolt goes in, but it's usually absolutely stopped by this thing here. So let's see if this needle can actually penetrate it where the normal bolt from the Siege cannot. And also, we'll use ballistic gelatin. Now it is time to test the indestructible EK Archery target mat. And of course, we will fire a regular bolt first without any special tip. Just 75 joule field tip, and see if the target mat is going to stop it. And I think it will. Okay, then let's aim a little bit to the left and a little bit high so that it works. Okay. So as predicted, the arrow sticks in the thick mat here and can be removed without major pain. It just sticks in a little bit, but you can easily get it out after a while. That's it. So it is intact, but of course so is the backside of the target mat. And now we will test the super high penetration bolts. Okay, we will try a little bit lower and also to the left. Let's see what happens. Okay. Wow! It went through. Okay, as you can clearly see, the bolt just penetrated just as normal, but here is the needle, and it sticks super firmly into this specific, bulletproof, not bulletproof, but bullet ready catch box here, made of steel, made for firearms. So it sticks in super hard. Let me see if I can get it out. No, it broke off. And this here penetrated just as deep as the original bolt, which is no surprise because it's pretty much the same thing. And as you see, it's fully intact. So here is the ballistic gelatin target, and I put a little bit of a leather jacket, an old leather jacket in the front here to make it even harder to penetrate. And this here is not ordinary ballistic gel, but it's my 40% concentration that after tests on when I had material from real gunshots, I found that this is more realistic when you compare behavior in flesh. And this is a 50 centimeter long piece. I will have to shoot at point blank because I have to really try to shoot straight into it, because as you see, the block is pretty narrow and I don't want to miss. Okay, first we will shoot with a regular bolt to calibrate the whole thing. All right, let's see. That should be about right. Okay. And go. All right. That was pretty decent penetration. So the whole bolt entered, and of course it cut through the leather. That's an impressive result, I think. Now we're testing the new bolt. Let's see what kind of result we can expect. I go a little bit more to the right. Okay. Obviously, the needle did not go out. It's still in there. Maybe there was too much glue. I think there was too much glue, and this time we will try again. But you see the penetration was a little deeper, and that is because the mass of that bolt is higher than the mass of the first bolt. You can clearly see that the penetration was a little better. So now we're using the one without any glue. Let's see what kind of result we can get. Okay, and fire. This time it worked. Yeah, you can clearly see that the bolt entered here, a little bit on a downwards path, and the needle is here. It almost pokes out through the back. So of course it deviated a little. Of course, no, actually not much. If you really follow this, then you can see that it's really pretty straight. So that was a super success, because look at how much more penetration we gotten from this. Okay, now just for the sake of comparison, we're going to fire a relatively standard 45 ACP round from this pistol into the block 2. I expect that it will go all the way through, but just let's check. Okay. I think I'm gonna go down on my knee. Ha! Didn't go all the way through. This is really interesting because here is the bullet, and as you can clearly see, it even turned around. So it tumbled at some point and then it turned around in the gelatin, and you can see how dense this mass is. This is so dense that actually it's a huge amount of resistance against these bullets here. So cool. While looking at the wound canal, quote unquote, I noticed that it might have interfered with one of the bolts that already are in there. So I will now try to hit it a little bit lower so that it has a virgin path to the gelatin, because that might make a difference. Let's see. Nope. Well, it did go in more far and it did not turn around. So that twisting probably comes from the collision with one of the bolts that are already in here, since that was really almost the same canal. But this time it came in a lot lower, and as you can see, it's a pretty straight canal here through this. But the penetration of the needle clearly is larger than the penetration of the 45 ACP round. Now, while we are at it, let's see what the 22 can do. The 22 has much less energy than the 45, but it has a much smaller diameter. So it should have really good penetration, even though it's not that big of a round. I go a little bit to the left this time and low. All right. Okay, that wasn't even as deep as the 45. So you can clearly see that the 45 penetrated way deeper. The 22 had about the same penetration, just maybe an inch more than just the bolt. So penetration was very comparable, but look, it actually turned around. Look. So the same thing that happened to the 45 in the first shot also happened here, even though that clearly did not collide with anything. So somewhere along its path, it must have twisted, and I think that is what this very dense gelatin is doing. Just out of curiosity, what is this Handgun 12 caliber semi-auto gun is gonna do when you shoot a 1276 Magnum round? And this is actually loaded, I think, with 3mm shot. So this will be a lot of little individual balls, and I'm going to fire it at really point blank. So that should have tremendous penetration, I think. Okay. I think it's fun that this has a tubular magazine. And I really love the design of this thing. It's really so cool. And it will have a decent amount of recoil. Wow, look at that. Look at the hole it punched through the leather. And actually that's the leather patch that I found inside here. And look at the energy that it transferred to the block. It actually tore it apart. But look at the penetration. No pellet penetrated deeper than here. So I have to say that, you know, and this is all completely virgin. There's no pellet in here. So I think that it's pretty clear. Penetration ended, and I think that's because the individual pellets did not have enough inertia, not have enough momentum to really go in any deeper. Did I just create a crossbow bolt that has higher penetration than a 22, a 45, and even a 1276 Magnum? Amazing, from a pistol crossbow with just 75 joule. I think that's quite an achievement, would you not agree? And physics explain that effect, because I generated a table where you would see the handgun calibers, but you would not only see the joule that they achieve, but you would also see the energy density. So you would see how much energy they have per square millimeter or square inch or per square centimeter, it doesn't matter. And then you can compare the energy just per surface. So, and that makes it very clear why these needles penetrate so well. Because actually the 45 ACP has only about 481 joule per square centimeter, whereas my little needle here has, at just 31.7 joule, has 1246 joule per square centimeter. So it's like almost 3 times as high, the energy here. And if I look at the chart, then it becomes quite clear that if you want to exceed that energy density per square millimeter or centimeter, you would have to go to the 44 Magnum. Only the 44 Magnum would be better than this. So the 357 Magnum is almost at the same value, a little lower. The 9mm Luger is much lower at not even 800 joule per square centimeter. Yeah, and the original crossbow bolt only, so without the tungsten tip here, only has 170 joule per square centimeter. So no wonder that it didn't penetrate very far. The energy density was just not high enough. It was just so high that it decelerated the shaft and prevented it from further penetration. Isn't it great when physics prove an experiment or the experiment proves physics? Boy, I love it when things work. I think I just invented a whole new type of crossbow bolt. Basically, it's the same principle as like armor breaking rounds for bazookas or guns, anti-tank guns. So, they also shoot a much thicker projectile, and then they have a high density, typically uranium core that actually will penetrate so much easier. So this is the same principle, but of course applied to crossbow technology. Now, and by the way, I used way too much glue on the first one. I was actually really, really hard to get it out with using the pliers. So that was actually too much glue, so I learned from this. Anyway, penetrates better than a 45 ACP. Who would have thought? Outperforms it. It's so much power. Will I make a commercial product out of this? No, I don't have any such plans because there's really no application. I mean, if you really want to kill someone with a crossbow, just use a hunting broadhead, and you got all the killing potential that you can possibly ask for. This is just to explain the physics behind penetration and to show you that energy isn't everything. It's actually energy per square millimeter or centimeter or inch or whatever. That is much more important than the energy itself. So this 75 joule, maybe 50 foot-pounds little dart here penetrates better than a 500 joule, 350 foot-pound 45 ACP round. That's really impressive. Anyway, I hope you like this because that's it for today. Thanks and bye-bye.